You don't understand that what I might refer to as data and study is not quite the same as what Dr. Rangan is referring to or Dr. Hospital is referring to. And in fact, that is the case, because our disciplines and our approaches are all different. Where Gene and his agency would typically lend to monitoring and collecting air data, have the monitor out there, suck the air in, collect the samples, and have it analyzed. Dr. Rangan would begin with maybe surveys to the community, looking at health outcomes or consequences, adverse health effects, problems that they may have physically, and document those. Me, on the other hand, I'm one that uses computer models and simulation and other empirical data, that is data that is actually real, to try and simulate what the effects are on the community. The approach that I use is one that's used throughout the world, throughout the United States, throughout California, for all its toxic assessments. And so, in that respect, what I was hoping to get, and what I think we did get some consensus with the group, that due to the type of studies that are available, due to the monetary limitations that we have, that to collect the data now that would be used in a model simulation to try and look at the extent of both the pollutant emissions, adverse health effects, and odor. My original thought was that if we could get good ground operations information, where did the planes queue? How long were they there? The number of planes that were in queue. If we had that information, good information, real information, we could basically program it into this very sophisticated computer model, and we could basically, with real data like meteorological data and whatnot, how the wind blows in your community, predict where this goes. We would establish a baseline, what you're breathing and what you're sensing now. We could then take that information and arbitrarily manipulate it. Let's see, let's move the line back here. Let's get rid of half the aircraft. Let's cut the idle times by a third. We could play this chess game, so to speak, to get some idea that if we were to do these things, we might be able to reduce the extent of emissions and severity emissions in the community. That was my goal and my hope in having information collected through the bills that were introduced by Assemblymember Liu. Unfortunately, that didn't happen, and we don't have any data in that regard. And we are hoping this time to have the legislation pass where we have good data collected so the scientists can take this information, like myself, look at it, and hopefully put it to good use so we can come up with some concrete recommendations to reduce the odor and the risk to the surrounding community. Thanks. Appreciate it.
Thank you, Bill. I'd like to ask both Philip Fine, Dr. Fine, and Dr. Hospital to give a short briefing about the South Coast AQMD airport study that they've been undertaking for the past going on a couple years now, to formulate the results of it. And how about we start with Dr. Fine? Could you give your title, because I know you're doing all the measuring and I just didn't write your title down.
Sorry, thanks Marty. Yeah, I'm the Atmospheric Measurements Manager at South Coast AQMD, which means I'm in charge of all the ambient air measurements we make across our jurisdiction in the 4-county area, both permanent monitoring stations that measure air pollution against national ambient air quality standards, as well as special studies such as this. And at any given time, there's 10 to 15, 20 special studies like this going on throughout the basin. This one has been a very interesting one. The reason I wasn't on the panel last time, I think, was because I wasn't at the AQMD yet. So when I started almost 2 years ago, this study was already underway. A lot of you have probably seen me present some of the preliminary results, and we're working on the draft now. Hopefully within a month or so, that'll be complete, and nothing's really changed from those preliminary findings. One thing to keep in mind is that the study was kind of modeled on our MATE studies that Dr. Hospital talked about. And these studies are focused on longer-term exposure and longer-term risk. And like Dr. Rangan said, you kind of almost have to separate sometimes the what you would consider long-term exposure for chronic health risks and acute exposure, which can happen, and the risks from acute exposure. So this was, the way this study was designed was to look at longer-term ambient concentrations of air toxics. And when we do that, we measure like 24-hour samples, longer-term samples over longer periods of time. Now, as you know, jet aircraft, come and go. You might get a spike. You might get that smell at any given time, and then you might have a few minutes, even an hour or so, and you don't smell anything. So the results I'm going to talk about, you have to keep that in mind, that we're looking at longer-term exposure. So just to briefly summarize some of the results that some of you have seen already, there is some good news, and that is that when we look at things such as particulate matter mass, one of EPA's criteria pollutants, and a lot of the volatile organic compounds, such as benzene and some of the other mobile source pollutants, that the levels we found in the community were not terribly elevated above what we find elsewhere in the basin. Again, this is longer term. It doesn't mean that when a jet is taking off for a few minutes that you wouldn't get a spike, but when you average that data over our samples over 24 hours or 8 hours in some cases in our studies, it doesn't show significantly higher numbers. There are certain seasons, there are certain samples that we saw some higher numbers, but in general, when you average it out over these longer term studies, it was I guess the best way to do it is inconclusive. If it was elevated, it was not elevated in a statistically significant way above what you would expect elsewhere in the basin. And also what we do is, like Dr. Ospital mentioned, is we look for gradients. We put out several monitors, and if there was an airport influence, you would expect that the monitors closer to the airport or closer to the runways would show higher levels, and as you moved away, they should drop off. So just looking at those trends, it was inconclusive whether the airport was contributing to certain pollutants such as PM and some of the VOC air toxics, formaldehyde, acetaldehyde, et cetera. Now, we did have a couple of significant findings, and one of those was lead, actually. And then we look at those gradients of lead, and when we're very close to the runways, or even across the street in the communities of the runways, we did find that there was a gradient of lead that decreased as you moved away from the airport. Now, these levels were still probably 10 times lower than what the US EPA or the California Air Resources Board considers the ambient air quality standard for lead, but we did have that finding. Now, lead is a component of general aviation fuel for the propeller-driven planes, so we don't think that's a jet issue. It's probably coming from the smaller aircraft. The other significant finding was we did have a couple monitors out there that were better than these longer-term chronic exposure studies that take these longer-term samples. We had a carbon monoxide monitor that can give you numbers, on a minute-by-minute basis, and we had what's known as particle counters, and they were measuring ultrafine particles. The carbon monoxide showed very low levels throughout, almost at our detection limits. However, the particle number counters, ultrafine particles, were significantly elevated. This was not an unusual finding. Dr. Freunds probably mentioned it if he was on the panel last time, and he's done some studies at LAX. And when you're near the runway, you do find significant spikes of these ultrafine particle number concentrations when a jet is taking off. And one of the big questions for us is, what does that gradient look like? How far does those elevated levels extend in the community? And we did find that it did extend probably up to at least 200 or 300 feet into the community where residents live. And this is kind of in line with some other studies that have been done next to freeways, where particle number counts, the very, very small particles, are elevated in that first 100, 200, 300 meters next to a freeway. Also similar to those studies found that even next to a freeway, the PM particulate matter numbers are not significantly elevated, even when you're sitting right next to a freeway. So that's kind of similar to what we found with these airports. So there was those two findings, and there was a third continuous instrument we had out there, and that was actually the noses of my staff when they were out there taking samples. And they did smell the odors that everyone here has smelled. It is real. It's possible we will not pick those up in the way that we sampled, though, for two reasons. One is those odors may be caused by things we either can't measure or are not considered, quote, air toxics by EPA, so we did not quantify those. And the other reason is if they are short-term, we may not pick those up in those longer-term samples. So Again, I think the study was important. It